Okay, so 12s. You got 8.2, 8.3, and 8.4. It's probability. There are three components to probability. Listening, boys? Thanks. Grab a pen or pencil and we're going to start. I'm going to summarize it for you because I think some of it you already know intuitively. So I'm just going to give you an overview how you're going to revise till the end of term 1 at the moment. So, what's 8.2? This is the stuff that you know when we say probability. Anything to do with probability, like if I said, what's the chances of getting tails when you flip a coin? What would it be? 50%, right? So 1/2, that's called theoretical. Yeah, so we call this 8.2 theoretical. Okay, so theoretical probability means that it doesn't actually mean it's true. It might be true in the long term. 8.3 then is, they call it relative frequency, but really just means experimental. What does experimental mean? It just means if I actually gave you each a coin now, and I said flip it 10 times, we know the reality is that not all of you are going to get the same amount of tails and heads. Okay, so Billy could get all 10 tails, Connor could get 5 and 5, Josh could get 3 tails and then 7 heads, okay? So we don't know. Each one is going to be slightly different, so that's called experimental, so it's relative. Okay, so the name for it's called relative probability. So that's the difference between the two. And the last one is called simulation. This one is an Excel program, and I've already got it set up as notes. So you just need to understand that in the long term, which is how gambling works, or casinos, in the long term, experimental becomes theoretical. Okay, and that's the final part. So 8.4 is just saying, if you do it for the long term enough, it does become a theoretical probability. And then I prove it to you with Excel for 8.4. Yeah. 8.4. No, but you have to be able to interpret. So they might say something like, they'll give you data, you read it, you find the percentages, and they say, in the long term, what do you expect, or how many people do you expect for the company to have more than 3 cars? Then you have to be able to say, well, in the long term, based on the probabilities, it should be about 30%. So something like that. So that's what that last one is. So it's interpretation. The Excel part is just for me to prove to you that experimental does become theoretical. Yeah. All right. So theoretical is pretty easy. So let's go through the terminology that you should know. Sample space. It is a list of... Anyone remember what sample space again? Billy?
Any.
All. Okay, so sample space, what does that mean? When you think about sample space, it just means what's all the possible outcomes you can get. So for example, if you roll a dice, the sample space is all the possible results you can get. So if you roll a dice, what can you get? 1, 2, 3, 4, 5, or 6. That's called the sample space. Okay? Give me another one. If I flip a coin, what's the sample space for flipping a coin? Heads or tails. Very good. That's called sample space. Theoretical probability, you all intuitively already know. It's the number of what you're looking for versus the total number of outcomes. So if I asked you, what's the probability of rolling a 3 in a normal dice, you would say the answer is, let's go with Connor. What's the chance of getting a 3 when you roll a dice? 1 in 6. Thank you. There's only 1 3.
No, you know what I meant.
I think I know what you meant, yes. 1 in 6. There's 6 options.
There's 6 sides to it. I'm not even explaining.
All right, good. Don't try. It sounds worse. Sounds worse if you try. Now, so that's theoretical probability. So number of what you're looking for. So there's only 1 3 out of the 6 options. Now let's look at experimental. So this is the probability of your current results. So for example, if I asked you to flip a coin 10 times right now, there is a possibility that you could get tails, 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 tails. Then what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So if I asked you now, what's the probability of getting tails in this one? This is relative and this is experimental, different to theoretical. What would the answer be for this one? Let's go with Jasper. Yeah, sure. 60%, very good, because we got 1, 2, 3, 4, 5, 6 tails. out of the 10 flips that we've done. Okay, but we know the reality theoretically. So this is experimental. Very good. Theory-wise, it should be 1/2. Okay, so that's the difference between the two. One's half, one's 6/10. Okay, and 8.3, 8.4, I will then prove to you that that's true. It actually comes out to be 50-50. Last terminology that you need to know, complementary. What does that mean again? The notation looks like the dash. So let's say, so probability of getting a 3, you told me is 1/6, but if I asked you what's the probability of complement of 3, which means 3 dash, what does that mean? Callum? 3 and 6? Not. 3, 4, 5, 6. Almost there. What does the dash mean? Okay, so write this in. Is the probability that the event will not happen. So when I say this one means getting a 3, when you put a dash, it means not getting a 3 because you're not going to get a 3 at all. So it's not happening. So if it's not happening, what's the chances of not getting a 3 at all? 5 out of your 6 options, there's one that you might get a 3. So therefore, it should be just a joke. All right. So chance of not getting a. So write that in. Write that in to remind yourselves. Complement, which is the dash, it means not getting what you want. So this is getting the 3. This is not getting a 3. Okay? All right, team. So let's do an example, and then we'll flip over to do a problem. Here's the first example. Nathan has discovered that 35% of students use Facebook for social media purposes. State the complement of this event. So read the question. So the chances of picking a student that uses Facebook is 35%. So if I say the complement of that event, what does that mean?
Nathan needs a job.
Read the question properly. Think about it.
35% of students use Facebook for social media purposes. State the complement.
So 13 out of 20?
65% of students don't. 65%.
It's 65% because 35% of them use Facebook. Complement of that means not using Facebook. So what's the chance? Is it? Man, you did it so quick. I didn't even know. How'd you do that in your head? 65 on 100. Is it 13? Is it? 65 over 1.
What's 13 times 5?
Oh, you're right. Holy cow. He's right. That is badass. All right. So, not Facebook is 65%. And like Jasper said, that's 13 out of 20. That's pretty epic. 65% was good enough. But yes, he's already simplified 65 over 100. Boys, not in my class.
Time and place.
Time and place. Do it at home. Do it on the footy field. Not in my class. Okay?
Just stop chatting, bro. So they not.
So you know you got.
No, they didn't.
He was on the ground.
But he's not perished.
Yeah, because he felt bad.
Good. So your
Archie
sympathy.
almost took his head off. He's like, oh, maybe I won't.
It's good. We've got some heart in this class. That's good to know. All right.
Archie as well, took a lot of shit.
You don't want to stir this up for the next time you're going to be on the field. So it's good that these boys are nice. Here we go. B. Calculate the probability of the complement of this event. Give your answer as a percentage. So the percentage was 65%. When they say state the complement of this event, you just got to say this is chances of not using Facebook. That's what the statement means. So you're finding the chances of someone not using Facebook. So you know 35% of them use, then there must be the leftover, which is 65% of them don't use. Okay? Now flip over the page. This one, can I go show of hands? Do you guys know how to play cards?
Yes. Wait, what type of...
Just normal cards. Yes? Okay, because there's some students who don't know. If you don't know how to play cards, I'm going to quickly teach you here.
Hold on, sir.
How many cards are there in terms of like numbers?
52.
No, that's 52 in a deck, but in terms of different types. 13. There's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so ace is 1.
Are you stupid?
Oh,
Are you built
in a lab?
And then it's 10, and then you got Jack, Queen, King. And then clubs. I mean suits.
I need a job.
There are 4 suits. So 4 times 13, 4 groups of 13 is then 52. That's why they say there's 52 cards in a deck. Okay? So that one you need to know. That's prerequisite knowledge, general knowledge that they might ask in the exam.
So ace is worth 14.
No, ace is worth 1 or 11.
I was mocking him.
Oh. 1 or 11 if you're playing blackjack. But in this case here, ace is 1.
That's not worth 14,
Okay.
bro.
Blackjack's 11.
Yeah, it's 1 or 11.
Oh, you're so dumb.
It's 1 or 11.
Just
All right. Let me go. Let me go on to the next one. Now, you got a normal pack of 52 playing cards. They're all shuffled. Now, you're going to pick one card. Okay, one card is shown. So calculate the probability of drawing a club. Now, for those who don't know, there's the symbols. This is the spades. So spades kind of looks like a spear. Okay, so that's spades. Clubs is the one that looks like a clover. And it's black. That's clubs. So you do need to know that a deck of cards has 52, and you need to know that there are 13 types, and there are 4 suits.
You need to know the suits,
Yeah,
How do you not know
because sometimes they ask you. They might say, "What's the chance of getting a club and a diamond?"
Do you have a life?
Yeah, but
Do you have a house? Do you have a phone? Do you have anything? I'm starting
Um,
to believe
the first one
you go
was
home and
13
charge,
out of
mate. You
52.
actually are a robot.
Which
Shut up, bro.
summarized down is.
why is it
Can you
national?
simplify that?
You can look at the diagram. So these are all the clubs. Now, if the rest is 52, how much is that portion? Look, there's 2, 3, 4 of them, and you got one of them.
1 in 4.
It's 1 in 4. 13 over 52 is equivalent to,
Oh,
yeah, so it's 1 in 4. So probability of clubs, write this in, boys. Boys, please stop talking while I'm speaking. So probability of getting clubs, yes, you're right, it is 13 out of 52. And we can already see in the diagram there, that's one entire row out of 4 possible suits. That's why it's a 1 in 4 chance. Do you need to know it's 1 in 4? No, because you get a calculator. You can type it in your calculator, and it becomes 25%. For those who don't know how to type in your calculator, it's 13, and that symbol means divide. Type 13 divided by 52, and you should get 0.25 on your calculator. So in the exam, they don't expect you to do the fraction component. They only expect you to know how to use your calculators to find the percentages. Okay, so this one would be 25% or 0.25. B. What's the chance of getting an ace? Good. So there's only 4 aces out of 52 cards. 4 out of 52. And again, you don't have to simplify this. Even though you could, it will be 1 out of 13. But if you didn't know that, you can just use your calculator and do 4 divided by 52. And that gives you 0.769, roughly. Okay, so 0.0769. So roughly 7.6%, or 7.7%. Okay? And your last one, what's the chance of getting a red queen? Be careful.
3 out of. There's 6.
2 out of
6.
52.
No, 6 out of 52. Oh, there's only. How many coins?
2
2
out of
coins. Yeah, there's 2.
What was that again?
2.
Not 6?
2.
2. Why 2?
There's only 2 red coins. 4 coins. 4 coins.
There are only 4 queens, so remember, each queen, there's a queen of clubs, queen of diamonds, queen of spades, and a queen of hearts. But out of those 4, there's only 2 reds. 2 reds. Queen of diamonds and queen of hearts. So that's why probability of getting a red queen is equal to 2 out of the 52 options that you have. Type in your calculator, 2 divided by 52. 1 over 26, which is 0.038. 0.0384, which is roughly about 4% or 3.8%. Okay? So I'm going to write the percentages on each side, and that's exercise 8.2. So this is 7.7% roughly, and that's roughly 3.8%. Right, team? I'll stop there. That's 8.2. That's called theoretical probability, that we know in the long term that's true, but in the short term it's not true.
Is that all we gotta know?
That's what 8.2, yeah. So the probability
So
component,
it's much easier than general.
yes, it would be.
Generally, I can learn 5 topics for 5 days.
5 topics?
8 days.
5 exercises, you mean?
No, there's like 5 different things we can learn for 1
You have to go over 2 exercises period.
Say that again?
2 exercises period.
Really, for general?
Yeah.
And you have to do it
Now,
at home.
some days it's 1.
No, you just do it at home.